Okay, let's take a look at another example. Suppose I have x cubed, so this is problem 18, x cubed minus 3x squared, and we want to find all critical points. So the first step is obviously take the derivative. So your 3 is going to come down, you get a power of 2. 2 times 3 is 6, and you, really to the first. Now, to find the critical points, what are you going to do? You're going to set this equal to 0. Please don't use this one. Factor out. You could pull out a 3 for both of these and an x. Do that. Why do I have you doing this? Because when I set the derivative equal to 0, it's the product of three things, correct? So either a 3 is 0, which is nonsense, x is 0, or x is equal to 2. Much easier to use the factored form for the derivative. So we set, so ddt subscript 1 means what? Don't do this. Don't set this form equal to 0. ddt subscript 2 means do this. Set the factored form equal to 0. So that means either this is 0, or this is 0. And that's all we do is we figure out, okay, obviously 3 cannot be 0. So x is 0 or x is 2. That's the only way you're going to make this 0. Those are your two critical points. Alright, so what we do is we create regions. So the derivative here is 0, means it's what? The slope is 0. Someplace in here, the slope is 0. Remember the idea of my hand? I'm giving you a number, and I'm telling you it's not 0. Means it's either a positive number or a negative number. So what we're going to do is the same thing, except three regions. So I have to figure out, is the derivative positive? If that's the case, comes up. If this is negative, comes down. That's positive, or it could be the reverse, correct? So what we're going to do is we look at each region, and we pick nice test points. So I'm going to pick a test point in here. Is the slope positive, negative? Test point, same questions. Okay, so for example, that's a little better. So what we're going to do is, again, pick nice test points. Please do not use this version. Use the factored form. Okay, so in region 1, I'm going to pick a nice, remember what our regions look like? Right here. So I'm going to pick a nice test point to the left of 0. Then I'm going to pick a nice test point in here and a nice test point in here. So for here, test point is going to be what? Negative 1. From here, what's the nicest number I know between 0 and 2? 1. What's the nicest number I have to the right of 2? 3. That's how we're going to pick our test points. So if I pick a negative 1, I'm going to put the negative 1 into here, here, here. 3 is a positive number. Don't worry about it. So I'm going to put a negative 1 in here, a negative 1 minus a 2. And I don't care what this number is. All I care about is it positive or is it negative. The 3 is a positive number. This is a negative number. This is also a negative number. Please don't tell me what this number is. All I want to know, is it positive or negative? Two negatives or positive? What does that mean? It's increasing. We do the same thing for our nice test point in region 2. Now we were going between what, 0 and 2. Nicest test point between 0 and 2 is 1. I put in a 1 into my factored form, not the expanded form. So I just put in a 1, positive, positive, this is negative. Please don't waste your time calculating what that number is. Is it positive or negative? It's a negative number, implies, right, you're decreasing. Region 3, I want nicest number to the right of 2. How about 3? Put the 3 not into this form, but into your what? Factored form. Ask yourself the question, is the derivative, please don't tell me that this is what this number is. positive, 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 which means it is what? Increasing. It means the function, okay. It means in here, the function is increasing, decreasing, and then what? Increasing. We're getting a very, very, very rough sketch of what the graph looks like. Okay, so where is it increasing and where is it decreasing? It's increasing where? In this region and in this region, right? So what is region 1? All the way out to negative infinity up to what? 0. You do not include 0 because here the derivative is equal to 0. It's not increasing or decreasing. Or from 2 to positive infinity, you don't include the 2 because it's 0 right there. So it's increasing either here or here. Remember this symbol from Math 143. It's decreasing between 0 and 2. You do not include the 0 or the 2 because the derivative is 0. There's your critical points. And it looks like the whole idea here is in here you're increasing, then you're decreasing. So it looks like it's a local what? Max. You're decreasing, then you're increasing. That looks like it's a local min. Is that okay? Let's take another example. Suppose I give you this guy right here. Can you see that? Well, okay, so I give you my original function. Take the derivative. 3's cancel. I'm left with the power 2. 2 times 3 is 6, and the derivative of 9x is just 9. Derivative of what? Straight horizontal line is 0. So now we're going to play the same game we played earlier in the semester. I'm going to take this thing and I'm going to call it something. Okay? Now this one's probably pretty easy to factor, right? The only factors of 9 are 1 and 9 and 3 and 3, and that's how we get. Suppose we don't know that. Quiz 1, I think it was, and test 1, I suggested, let's put a number here for x and see what we get. So if I put in a 3, and I do the arithmetic, 9 plus 9 is 18 minus 8. It's 0, which means what? X minus 3 is a factor. That means we can do our long division, correct? In other words, when I take x minus 3, that should factor into this. Now remember, if there's a term that you don't have, like suppose you didn't have the 6x, you would put 0x. Alright, so what times x gives me an x squared? It has to be x, multiply both. So you're thinking of this as long division. X times x is x squared. Minus 3 times minus 3, excuse me, x times 3 is minus 3x. Now subtract, which means whatever is positive is now negative. Whatever is negative now becomes positive. If I've done things correctly, notice x squared is cancel. Minus 6 plus 3, I get a negative 3x. You now bring down the 9. What times x gives me a negative 3x? Obviously negative 3. Multiply. And negative 3 times negative 3 is 9. Guess what? Your remainder is 0. So that means the derivative, which I just called a different something else, can be factored into x minus 3 times x minus 3, which is really x minus 3 squared. Okay, so the only critical point is where? At x equals 3. So what I do is I look on both sides of 3, break it up into 2 regions. Remember my hand? I have something that this number is not 0. It means it's either positive or negative. It's either positive or negative. So we're going to pick a test point, say in region 1. The nicest number I know to the left of 3 is 2. Please don't put this into your expanded version. Put it into here. So 2 minus 3 squared, notice it's a negative in here, but you're squaring it so you get a positive number. This means it's increasing. We do the same thing for, if you guys can see this, to the right of 3. What's the nicest number to the right of 3? 4. Put it in. Notice when I square a real number, I always get a what? Positive number. So this is telling us, okay, pages are all stuck together. So this is telling us, apparently, this function is what? Increasing in both region 1 and region 2. So we're going from minus infinity out to 3. Don't include the 3. Or 3 to positive infinity. And that takes us to